It is a diagrammatic representation of the sets and the properties of sets is called nothing but the Venn diagram. Under the universal set, you are going to get the set A and the set B, which is written in the form of a circle. Then can you guess, dear students, what is B minus A? B minus A means which are in B but not in A. That is going to be known as B minus A. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram, the Temple of Excellence, Mysuru. Okay, in this session we are going to learn here the sets, relations and functions of session 3, which is a chapter number 2 in your NCERT textbook. So what are the topics we are going to study under this session, dears? Let us look into the this is Venn diagrams. So how we are going to write the Venn diagrams? What do you mean by the Venn diagrams? How we are going to solve the problems by using the Venn diagrams? Okay, so in this session let us look into the definition of the Venn diagram here. What is that? Venn diagram means it is a diagrammatic representation of the sets and the properties of sets is called nothing but the Venn diagram. Got? And then in the name of the famous mathematician who developed this is nothing but or devised this is nothing but the mathematician called as Venn. So that the name here they have given the mathematician name only it as Venn diagrams. So how Venn diagrams will be useful here? So how we are going to represent the Venn diagrams for different kinds? Let us look into that. See, a set is represented by either the circle or the closed diagram. So either like this you are going to represent or like this you are going to represent the set. Okay, and inside the set you are going to write all the elements by like this. Here 1, 2, 3, 4, anywhere you can write here 1, 2, 3, 4, 5, 6, 7 or A, B, C, D. Anywhere you can write inside that set. These are going to be known as elements or the objects. Understood? So we'll be moving on to the next. How we are going to represent the universal set? What do you mean by a universal set? The all types of the subset which will come under a set is nothing but the universal set. How we are going to represent in a Venn diagram, which is nothing but the rectangle. So this you are going to represent the universal set, and then you are going to write if the universal set, for example, in a class there are totally 50 students. Therefore, you are going to have the set is nothing but total set is nothing but universal set will be 50 students. Therefore, you are going to write it here U will be is equal to 50 students like that. Understood? Then, how we are going to represent the union of two sets? What do you mean by union of two sets? Union of two sets is nothing but the set which is can be written it as, what is that? The elements of all the either in A or in B or in both. The elements are written in the form of A union B. It is nothing but the all the elements of A, all the elements of B or all the elements of both A and B, isn't it? That is what A union B you are going to call it as. How we are going to represent in a set? This is how you are going to represent in a set. So this is what the A set and this is what the B set. The shaded region here, what you can see, the shaded region is something but this is what the universal set. Under the universal set you are going to get the set A and the set B, which is written in the form of a circle. So and then shaded region is nothing but the A union B. So if they ask you to represent how the A union B, this is a diagram you are going to write it as. Understood? So we'll be moving on to the next one, A intersection B. What is A intersection B? In the set A and the set B, which are all the common elements, you are going to write it under that A intersection B. Here, the shaded region is nothing but the A intersection B. You are going to write first as universal set and then under the universal set, set A and the set B, which is a common element. You are going to have it as this is a common path you are going to have here. So this is noted down as intersection of two sets and this shaded region is nothing but intersection of two sets, A intersection B. Understood? Next, how we are going to have A minus B. What do you mean by A minus B? A minus B is nothing but the elements which are in A but not in B. That is going to be known as A minus B, isn't it? So this is how we are going to represent the A minus B. The shaded region region is the A minus B. This is a universal set and this is a set A and this is a set B. Only this shaded part is nothing but you are going to have it as A minus B, which are only in A but not in B is nothing but the A minus B. Then can you guess, dear students, what is B minus A? B minus A means which are in B but not in A, that is going to be known as B minus A. Here the shaded part is nothing but the B minus A. So if they ask you to write the Venn diagram of B minus A, this is how you are going to represent. Are you getting this? So here you are going to have, this is the universal set you are going to have, and this is a set A, this is a set B. B minus A means only which are in B but not in A is going to be known as B minus A. Understood? Next we'll be moving on to asymmetric B. Symmetric means what? Which are in A minus B. Correct? You are going to have it as union B minus A. Union of these two is nothing but asymmetric B. How we are going to represent it as a Venn diagram? You are going to have, see, leaving the intersection, which is A, this is A minus B, this is B minus A. Union of that two is nothing but what? Asymmetric B. So this is how we are going to represent asymmetric B as symmetric difference. Are you getting this? We'll be moving on to the next, that is nothing but subset. Subset means what? The given set A and B, the elements of A which will be there in B, there we are going to say that A will be a subset of B. The elements of A contained in B, then we are going to name it as A will be a subset of B, and this is symbolically we are going to write it as, and this is how we are going to have the Venn diagram. So this is a universal set, and then you are going to have set A will be there. So and then set B, you can observe here, dear student, set A is within B, isn't it? Set A is within B, therefore A is contained in B, therefore A elements are in B. Therefore this is how we are going to write the Venn diagram for A contained in B. Suppose if they ask B contained in A, how we are going to write, dears? B contained in A is nothing but this is what you are going to have, the universal set, and then here it is nothing but set B, and here it is nothing but set A, and this is a set B, and this is a set A. Therefore we are going to write it as B will be a, B is contained in A, or B is a subset of A. Understood? You can have the difference between these two. Just we are going to write it as what? Set B will be inside because the elements of B will be there in A elements. Understood? Next we'll be moving on to what? The A dash. What do you mean by A dash? You will be given a universal set and then you will be given a set. Universal set minus given set is nothing but the A complement. We are going to write the A complement either A dash, or we are going to write it as A C, that is A complement. Understood? How we are going to represent in a Venn diagram? Venn diagram will be like this. Universal set you are going to write it as which are there in U but not there in A, that is nothing but A dash. This is how, which are there in U but not there in A, which is nothing but A dash or U minus A, you are going to write it. Understood? So these are all the Venn diagrams you are going to have for the union of two sets, intersection of two sets, and then A dash. Okay, here we'll be moving on to disjoint. What do you mean by disjoint? Where no sets will be can find out. That means empty set. So that means disjoint set will be like this. No will be combining. This is the set A you can have, this is the set B you can have. So this will be a diagram of a disjointed, and in disjoint set we are going to write it as A intersection B. Always it will be a empty set. Understood? This is how we are going to represent the disjoint set Venn diagram. Understood, dears? Yes, we'll be moving on to the list of the formulae. Based on those, how we are going to define the union of two sets by the formula to find out the what will be the given in the problem. So here, if A and B are the two finite sets, I am going to take it as finite set means it should be countable. Okay. So then N of means what? Number of. N of A union B. That means number of elements in A union B. Understood? Number of elements in A union B is known as n of A union B. Similarly, what is equal to what it is defined as? How we are going to write it as n of A union B as? N of A union B can be written as number of elements of A plus number of elements of B minus number of elements of A intersection B is known as n of A union B. That means what are all the number of elements in A, what are all the number of elements in B minus what are all the number of elements in A intersection B gives you n of A union B. Understood? Next we'll be moving on to the notification of the same here. If A intersection B like this, if it is a disjoint set, then we are going to write it as A intersection B will be equal to the value 0. If we are going to get it as disjoint set, A intersection B automatically takes the value as 0, then what will be the formula will become? Anything minus 0 will be a same thing. Therefore, if we are writing here, if n of A intersection B is, if it is 0, then if we are going to write here 0 as, then the remaining will be the formula n of A union B will be is equal to n of A plus n of B. Understood? Next we'll be moving on to, suppose if A intersection B is not equal to 0, then the same formula will remain. If it is equal to 0, then we are going to have it as n of A plus n of B, which is nothing but n of A union B. The number of elements in set A plus number of elements in set B, if number of elements in A intersection B is 0. Understood? So here we are going to have next is nothing but suppose if the 3 sets are given, here only the 2 sets I have taken and I have given a definition for number of elements or the formula for number of elements of A union B. Suppose if they ask you to do the problems of 3 groups. For example, here I have taken if A, B, C are the 3 finite sets, then we are going to write it as n of A union B union C. The formula will take like this, n of A plus n of B. That means number of elements of A plus number of elements of B plus number of elements of C plus number of elements of A intersection B intersection C. Okay, minus number of elements of A intersection B minus number of elements of B intersection C minus number of elements of A intersection C. Suppose if you are having like this A, B and then C, A intersection B, A intersection B and then B intersection C and then C intersection A. Like this it will go DS. That's it you have to remember, and number of you have to put the symbol n of A intersection B minus B intersection C minus C intersection A or A intersection C. Okay, intersection of that 3 elements you are going to have, and this is a formula which when the 3 sets will be defined. Understood? Next we'll be moving on to what is that? If A and A dash both are finite set, then we know that n of A dash will be is equal to n of U minus n of A. How A dash will be written? A dash can be written as U minus A. Therefore, what is n of A dash? N of A dash is nothing but number of elements in set U minus number of elements in set A. So this are all the formulas you have to, what is U? U is nothing but here you are going to have it as universal set. Understood? So therefore you have to remember all these formulas to solve the problems by Venn diagrams. Now what are the Venn diagrams? What we have studied till now, these are all going to be known as the Venn diagrams, and then based on this we are going to have these formula. By using the Venn diagrams or the formula, you can solve the problems of the 5 markers or 3 markers. Okay. So now let us look into the formula of the next one is nothing but if A and B are 2 finite set, then how we are going to write it as number of elements of A minus B. A minus B means what? Which are there in A but not there in B. But how we are going to write it as number of elements of A minus B? Like this. Number of elements of A minus B can be written as number of elements of A minus number of elements of A intersection B. This you have to remember. Number of n of A minus B is equal to n of A minus n of A intersection B, which are in common in both. Okay. Next, what is n of B minus A? n of b minus a is nothing but number of elements in set B minus the common elements of both A and B gives you the n of b minus a. This is the other formula of the a minus b and then b minus a. Number of elements of b minus a will be like this, n of b minus n of a intersection b, and number of a minus b is nothing but number of elements in set A minus number of elements in both set A and B, isn't it? That is a common elements. If you minus that, you are going to get it as number of elements of A which are there in A but not there in B. Understood? So these formulas you have to remember to solve the problems. Now let us look into the problem how we are going to solve by using those formulas, dears. Here in a class of 50 students, okay, 15 do not participate in any games, okay, 25 play cricket, 25 play football. Find the number of students who play both. Who play both means what? Who play both means which is a common, correct? Who play cricket also, who play football also. Therefore, the common people, common students will be there in that. Common means what? Intersection. Therefore, what they have given here in a class out of 50 students means u will be is equals to what? Number of elements of u. So, given here it is nothing but n of u is nothing but 50 students. 50 students. Okay. And then what they have given? 15 do not participate in any games. They will be not participating in any games means what I can write it as union. Union is nothing but what we are going to have football. Cricket I am going to take it as cricket. Cricket I am going to take it as let it be C. Football they have given it as football. I am going to name that one as let it be F. Okay, so therefore number of elements of C union F means what? This do not play means what we need to do? We need to minus from the universal set. That will give you union of the set where all the students will play, isn't it? Therefore we are going to have it as n of cricket union football, where all the students will play will be is equal to 50 minus 15 will be is equal to how many? You are going to have it as 35, isn't it? Right? So if these are all the students who play all the games, isn't it? But what are all the games they will play? How many students will play only cricket and how many students play football? In that 25 students will play cricket. Therefore, number of students will play cricket is nothing but n of C. Number of students who play cricket, n of C, is nothing but 25. Similarly, you are going to have number of students who play football is nothing but number of F. I am going to take it as n of F. N of F is nothing but you are going to have it as 20. 20. Now what they have asked? Find the number of students who play both. See, who play both. Who play both means common. Common means intersection. Therefore, what I need to find out? What is n of C intersection F? Isn't it? This is a question mark. Now, what we are having the formula? We know that the formula will be is equal to n of C union F can be written as n of C, number of elements of the cricket, correct, who play cricket, plus number of students who play football, correct, minus number of students who play both, that means intersection, n of C intersection F. This is a formula we can use. You can remember n of A union B can be written as n of A plus n of B minus n of A intersection B. Instead of A and B, I am going to choose it as here C and F according to the given question. C is nothing but a cricket here, F is nothing but the football here. That's it, dears. Okay. So no make such difference here. So here you are going to have, you can substitute what is n of C union. N of C union F is nothing but 35. Let me substitute here the value, number of students who play all the games, which will be is equal to number of students who play cricket. Cricket is nothing but here 25. Let me substitute here is equal to 25 plus number of students who play football is nothing but 20. So I can have it is here 20 We don't know this one. As it is, we are going to write it as n of C intersection F. So what we can do? We can take this n of C intersection to the left hand side. We can take this 35 to the right hand side. What it will become? Therefore, n of C intersection F will be is equal to, what is that? 25 plus 20 is nothing but 45. 45. Now take this 35 to this side. It will become minus 35. The answer will be is equal to n of C intersection F can be written as 45 minus 35, which will be is equal to 10. Okay. This is what you are going to find out. Okay. So this is how we are going to find out by using the formula. Understood? So therefore, how to write the Venn diagram for this one, dears? Let me write it here. Venn diagram means how the universal set is represented as. Universal set you can represent it as U, isn't it? So therefore, in the rectangle shape, this is a rectangle. You are going to have it as U is equal to how many students you are having? 50. So therefore, this is 50. You can have it as. Now, n of A and n of B. This is A. And this is B, isn't it? You are going to have it as. So how many students of the cricket will play? Cricket will be playing as 20. You are going to have it as C. This is F. So you are going to have here 25. Yes, 25 will play cricket. 20 will play football. So you are going to write it as 25 will play cricket. 20 will play football. How many will play here? You are going to have it as 10 will play here. The number of students who play, what is that? The who will play both, isn't it? But we cannot write like this. If we write like this, it will be wrong. Why? Because 25 plus 20, 45. 45 plus 10, it will become 55. So you have to divide now. Then you are going to write it as 10. You already know. 10 is nothing but what we have found out, isn't it? So therefore, who will play here? Both it will be there. Here also cricket and football it will be there, isn't it? So how many students left out here out of 25? 15 students is left out. So therefore, you can have it as here 15 students. So 15 plus 10. Because intersection means both it will pay. Cricket will students also will be there. Football students also will be there. But here only cricket. So adding these two will gives you 25. 10 plus 15 is nothing but 25. Similarly, you are going to have it as here 20. So already 10 are playing here. Remaining 10 will be here. This is how the Venn diagrams will go. Are you getting this one? So I think you got clearance about this. So 15 plus 10 is 25. 25. Again, if 10 plus 10 is nothing but 20. This is how the diagram will take place. Understood, dears? So you are going to have it as Venn diagram as like this, and this will be here who do not play anything. Where it will come, do not play here. Who do not play anything is nothing but the 15. Anywhere inside the universal set of the rectangle, you can mention them. Are you getting this? So 50 minus 15 will gives you 35, union of that set. Okay? You understood this session, I think, how to answer the question of the easier and how to write the Venn diagram and how to write the Venn diagrams for all union of two sets, intersection of two sets, A minus B and then B minus A, and then how we are moving according to the formula by learning or by having the Venn diagram and how to solve the problem. So thank you, dear students. In the next section, we'll be solving some more problems on the Venn diagrams. Thank you, dears.